Yeah. Yeah. So there's like one thing, you know, you're like, or speed, and the speed of the people.
Yeah.
Yeah, they're. No, you get fired like two bosses or whatever.
It's like the same.
She's like the same. She's like middle aged.
I don't know. One of the three.
Going for your whole. Yeah.
Yeah, so I didn't, yeah, so I didn't have any.
High school is more.
That's, yeah.
So today, we're gonna do some review for your quiz tomorrow. You guys can turn to page 23. We're still gonna get some more practice with coterminal and reference angles. We're gonna do the odds. We'll do the odds 1 through 19, just so that we can get that practice, make sure we still remember all the steps for coterminal angle and reference angle. I'll put the summary sheet up in a second so that we can review those things. But after we do that, maybe we can start on the quiz review. I like for the quiz review for you guys to either do with me in the help session or do on your own. That way you can kind of have a worksheet where you can see if you can do everything on your own. But I just want to highlight what you can expect on the quiz tomorrow. So you'll need to be able to convert from degrees to radians, from radians to degrees, find arc length. So that's on numbers 4 and 5. And then being able to tell if angles are coterminal, because, and the way you do that is, you know that angles are coterminal if they are separated by a factor of either 360 or 2 pi, right? So if I can take one angle and keep adding 2 pi and eventually reach the other angle, then I know that my angles are coterminal. Or if I take one angle and add 360, if I can reach the other angle, I know that they are coterminal. And then number 9 and A through D, being able to find the reference angle. Okay, so that's what you can expect on the quiz tomorrow. Should be a short quiz. We can maybe even spend the first few minutes just going over any questions that you guys have. Okay, I'll send out a reminder this afternoon. You make sure you have your calculators. I will use 5th period to go over this worksheet. Tomorrow morning, I need to do a help session for my calculus students, so the help session is going to be 5th period today. But if you can't make it, that's fine. I will record the help session 5th period, and you also have the key attached, so you can work at your own pace later and just check and see how you do. Okay, any questions about the quiz tomorrow? All right, so go ahead and start with page 23 and 24. We're just going to work through the odds. This is your classwork, and I'll work through the problem as you guys do it at the same time. Okay. Yeah, that's right. Yeah, between 0 and 2 pi.
Could you also add your 16 to 85?
Yes, that's right. So there are infinite numbers of coterminal angles. As long as you find one of them, So for 1 through 7, I'm just creating what could be an answer. So technically, you could have different answers for me for 1 through 7, and that's fine as long as you're following the rules of either adding, subtracting 2 pi or adding, subtracting 360.
I 2 pi, 2 pi. 2
Same for number 7.
Yeah.
Yeah, negative 9 pi over 2 also works,
Okay.
but I want one negative and one positive. So yes. So I got to add 2 pi twice to get to one positive angle, at least. Mhm. Oh, this right here?
Yeah.
Yeah, so this is considered a negative angle. If I want the positive angle, I gotta add another 2 pi. So that means 2 pi didn't get me quite to the positive coterminal. I gotta add at least twice. But because I added 2 pi and I got a negative, I can just call that my negative coterminal angle, and I added 2 pi again and got my positive. Sure. Give me 1 second. see number 5? Sure. Yeah, these are not the only answers. These are just the most convenient ones, the ones that are closest to the one that's given to you. Yeah, -9/2 is one that you can use for negative coterminal, yeah. And then 3/2, right? That's gonna be the easiest one to find. By adding 2 pi twice. Right, so anybody still need to look at any of the problems on the first page? Okay, no questions, first page? I'd be happy to go over any of the problems detail if you do have any questions. Okay, so you're good, first page? Yeah.
3 where it's 5/6. How do you know that that's between 0 and 3? You include the pi.
Yeah, you know it's between 0 and 2 pi because you look at the fraction. Right, 5/6 is a little bit more than 1, but less than 2, so it's clearly between 0 and 2. Yeah, so whenever you want to determine anything between 0 and 2 pi, leave the pi out of it, and just look at the number or the fraction in front of it and use that to compare. All right, good. Any other questions, first page? All right, let's go to the second page. But I'd like to review some of these concepts that we highlighted yesterday. Okay, we talked about how if I want to find a reference angle, I first need to locate a coterminal angle that is within an easy range for us to determine. So just like how we did on the first page, you can either add or subtract 2 pi or add or subtract 360 to get it into something that is between 0 and 2 pi or between 0 and 360. And then from there, step number 2 becomes a lot easier, which is identifying the quadrant that your angle is located. Okay. So if the fraction of your radian looks a little strange, look at what's in front. Look at that fraction in front, and you can use your calculator to get a decimal approximation of that fraction. If your fraction between 0 and 0.5, you know that that angle is living in the first quadrant. If your decimal is between 0.5 and 1, you know you must be in the second quadrant. If your decimal between 1 and 1.5, third quadrant. If your decimal between 1.5 and 2, then it's going to be in the fourth quadrant. So once you identify the quadrants, then you know which what to do. If you want to find reference angle, you're always going to be working with the x-axis. Okay? Your x-axis is going to be what you're always comparing with. Okay? If you're in the first quadrant, there's nothing that you need to worry about. You just leave it alone, as your reference angle is the same as your angle. But if you're in quadrant 2, you got to involve 180 and or pi, depending on whether you're in degree or radian. And you're always going to do larger minus smaller. So either 180 minus theta or pi minus theta. Okay. But if you're in the third quadrant, you're going to also involve 180. But the difference is that your angle is now larger than 180. So you're going to do that angle minus 180, theta minus 180 or theta minus pi. And then finally, if you're in the fourth quadrant, you got to subtract from a value that's larger than what you have in the fourth quadrant. So you got to subtract from 360 or 2 pi. Finally, just to make sure, so that you know that your reference angle is the reference angle, look at your theta prime and see if it's between 0 and positive 90. Okay. It should be a positive number. And then also, in terms of radians, look at your fractional value. If your fractional value is between 0 and 0.5, or which same thing as 1/2 pi, then you know that your theta prime is correct. It should be, even if that fraction looks strange, get the decimal version and make sure it's less than 0.5, and you know you're good. You know that's your reference angle. All right, any questions with these steps? All right.
Questions like 12 and 14 on the quiz.
Say it again?
Are we gonna have questions like 12 and 14 on the quiz?
Yes, so with those, you don't have to worry about the diagram. You just get those measures into something that you can recognize. So if it's a large angle, just keep subtracting 2 pi or add 2 pi or add 360 until you get to that nice range, and then follow the rest of the steps. Yeah. But yeah, I'll go through the odds. And I may even, yeah, I'll probably go for number 12 as well, just so they can kind of see what the process is if we're dealing with radians that's not inside that range. Yes, that's right. Yeah. Mhm.
What was the answer to like question 9?
Yeah, so question 9 was yes, because I can take that 115 add 360 and make it match 475.
So like when it asks if the given angles are coterminal, it means you compare them.
Yeah, you compare them. You see if one angle, see if you can reach from one angle to the other by adding or subtracting 360. Because if you can add or subtract 360 and eventually get to the other angle, that means they're off by a multiple of 360, which means that they're a coterminal.
Okay, thank you.
Okay, any questions with 11 or 13? Yeah, 14. Yeah, okay, I'll go ahead and do number 12 and 14 so you guys can see it. But any questions with 11 and 13? Okay, so number 12, I look at that 7/18, and that's obviously greater than 2. So I subtract 2 pi and I get 31/18. I test that fraction. Is that 31/18 less than 2? What's that decimal value, 31/18? Right, 1.72, so that's, we can look at that decimal and know which quadrant is that gonna live in. 4, right, because 1.7 is between 1.5 and 2, so you know that you're already dealing with something that is clearly in quadrant 4. And now we can find the reference angle, right? Reference angle for fourth quadrant, we're gonna involve 2 pi. You can double check, make sure that 5/18 is less than 0.5, right? Because your reference angle has to be between 0 and pi/2. And 5/18 is definitely a decimal value of less than 0.5, so you know you're safe. Your reference angle does fulfill that condition. Yeah. You mean this negative 655?
No, like I got when we did that and like my 65 is a coterminal.
65 is a coterminal angle, but it also is in the first quadrant. So
Oh,
if,
that's also correct.
right, exactly. So if your angle is in the first quadrant, that's the easiest one because you don't have to do anything. Your angle is it's already an angle between 0 and 90, so you're safe. You can just leave it alone. Yeah.
What happens if it's the terminal side is in the third quadrant? Where did you feel that?
Oh, you mean like number
I did an example, but what if there was?
you mean like for number 13?
They're not in the first quadrant, the second and third, like third.
Oh, okay, got it. Yeah. Good. So if you're in the second or third quadrant, you're gonna be involving the 180-degree line. You have to involve do either 180 minus theta or theta minus 180.
Ah, right.
Yeah.
Okay.
So you're always finding the closest x-axis and then using that and subtracting from it.
Okay.
I'll work through number 14. Negative 25/18 plus 2 is 11/18. And 11/18 is greater than 0.5, but less than 1. So we should be able to tell that this is quadrant 2. Okay, so I want us to be able to make all these determinations without the graph, okay? So the graph is not going to be given to you. We're going to rely completely just on your calculator and the radian or degree measure given. Yeah.
How do you do fractions on the graph?
Okay, so the way you do fractions, you're going to go to alpha button, and do alpha y equals, and then you're going to have this menu pop up. That's n over d. So if you click on that n over d, it's going to give you that nice math print fractional. Yeah. So alpha y equals. Quadrant 2. So I have to involve second the 180-degree line, the pi. Or which one? Yeah, so once we know what quadrant we're in, we can decide how we want to get to our reference angle. So then 1 minus 11/18. Which same thing as 18, yeah, minus 11, which is 7. And then double check, make sure that your fractional 7/18 is less than 0.5, and it is. So you know that is a safe reference angle that's between 0 and pi/2. Okay, let's finish off with 15, 17, and 19, and then we can begin the quiz review. Any questions? Does anybody still need to look at what I have up here? I'll leave it up for another second. Yes. We do. We're gonna work through 15, 17, and 19 as well. Yeah, so I did 12 and 14 because some students were asking about it. They want the extra practice, so. But let's go through 15 through 19 as well. I'll leave this up for another second. 16, sure. Yeah, let me get through 15, 17, 19, and we'll do 16 as well. Sure. All right. Okay, so if we want to find reference angle, first thing is let's make sure we can recognize what angle we're working with. And it's a lot easier to know what angle we're working with if we can get into something that's more recognizable. So I'm going to keep adding 360 until I can recognize the angle that sits between 0 and 360. And then I added 360 twice. I got to 210. And 210 is in the third quadrant. So now I know how to move forward, right? I got to involve that 180-degree line to get to my reference angle. Okay, 17 is pretty straightforward because it's already an easy angle to recognize. It's in the fourth quadrant. So subtract using 360. 19, I see a negative angle, so I'm going to add 2 pi. And I arrive at 2 pi over 3. Okay, which quadrant is 2 pi over 3 in? Quadrant 2, right? 2/3, that fraction is 0.6. 0.6 is greater than 0.5, but less than 1. That's clearly in the second quadrant region. And we know what to do with quadrant 2. We got to involve pi.
Like the fractions, pies. So no, not right.
Yeah, so I may ask you to graph these out, but you can just do a really rough sketch of where that graph is. Yeah, so here, yeah, go ahead. Question about 16? Yeah.
Have to be able to participate in resources. Like what we use as reference for the questions, because I know we have to subtract I minus. Like sometimes I forget like what it is.
Okay, so give me an example. Where you stuck?
Like like on this. What if I didn't know 60 and I didn't know that we had 100 rows.
Yeah.
I didn't know what we had to subtract. Right.
So, I mean, I'm not gonna give this to you. You have to draw it out at the beginning of your quiz. And that's your.
Yeah.
Okay, so 16, 19 over 9 is a little bit greater than 2. So we got to subtract 2 pi to get it into something that is clearly, well, between 0 and 2. So 19 over 9 minus 2. I get pi over 9. And pi over 9 is 1/9, and 1/9 is 0.1, which is much less than 0.5. So which quadrant is this in? Quadrant what? 1, right? So if 1/9 is less than 0.5, then it's already quadrant 1. If it's quadrant 1, do I need to do anything with this pi over 9?
No.
No, that's your reference.
Answer to 19.
Pi over 3. Cool.
So 19.
Let's see if we can start on the first page of worksheet 2. We need to make sure that we remember how to convert from radians to degrees and vice versa. So from degrees to radians, we multiply by pi over 180. From radians to degrees, we multiply by 180 over 5. Check your answer on the second page. The key is attached to your worksheet.
Get this.
No,
So, yeah.
you haven't memorized that, yeah.
So actually,
You just cross multiply.
No, I should multiply across. So 320 over 1. Yeah. But leave pi, well, I think you just multiply across. You only cross multiply if there's an equal sign in between.
Right.
Multiply across. All right, everybody okay with 1 and 2? Yes. Oh, yeah, do you pick this? Check here. Okay, guys, over 1 and 2, pretty straightforward. Number 3, arc length, S equals R theta. Make sure you memorize this formula. And then there's also something that we gotta make sure that we understand. There's something that we have to know about theta. What do we have to know about theta with this formula?
It sounds like central angle.
Good, central angle. What else? Good, so this formula is only gonna take radians and it's only gonna give back radians. If I wanna do any conversions with degrees, I gotta do that separate, right? I gotta multiply, or I gotta involve pi over 180 or 180 over pi. So we never want to put like, 36 degrees in here, or if we have a theta equals, 2, we have to understand that's radians, that's not degrees. So keep in mind that if something is not in the correct form, we gotta take a separate step in order to get that theta appropriate for that formula. Okay. All right, so number 3, find the measure of the central angle, that's theta, in both radians and degrees. But we'll just focus on radians first, right? The degrees, that will be a separate thing, because we know the formula will just deal with radians. So I'm gonna start using my formula here. Solve for theta, divide both sides by 6. Going to reduce that to a fraction, or reduce fraction. And I know that whatever comes from the formula is in terms of radians, so I can say that theta is 5 over 2 or 2.5 radians. But now separately, if I want to create the degree version of that theta, what can I do? Well, this is in terms of radians. I want to be in 180 over 5. Yeah. So basically, the numerator of your conversion is going to tell you what you want it to be, right? So if your 180 is up top, you know that you're trying to get to degrees. If your pi is up top, that means you're trying to get to radians. Yes. Yes, and decimal is fine. Yeah, so decimal is fine. Yeah, it says round to nearest thousands, so that's fine. Oh, 180 over 5. Right, because we want to get to degree. Okay, number 4 and 5, we're still using arc length formula, but we may be solving a different variable. So number 4, we're looking for the arc length. We're looking for S. What adjustment do we need to do before we can use the formula? That's right. So the 270 is not appropriate for the formula. I got to get that 270 to be radians, right? So what I do, 270 times what? Times pi 180. Once I get my theta in the appropriate units, now I can use the formula.
It's a 3 pi over 2. You just write it as a decimal to the fraction.
Yeah, that's fine. That's fine, yeah. I will say though that, okay, I think for right now, it's not a big deal. But I will say that the nice thing about holding that exact value is that your approximation will be more accurate than if you had a decimal here. But I don't think that's going to be a big deal right now, but down the road, we want to hold on to the exact value as long as possible, especially in the end if we're trying to get to an approximation that's as accurate as possible. Yes.
On the test, like, can we keep it in Python? Or like, we have to convert it?
Okay, good question. I will say, look at the direction. Okay. If the direction doesn't specify, then you can do either one. But the direction is specified, then you want to give the appropriate form depending on what's asked of you. Okay, so read the direction. Okay, the back page should be very similar to what we just did with coterminal and reference angles. Yes. That's telling you. Okay, I'm gonna have you guys, try to finish up six, on the back page on your own. It's not homework, I think, but it's just good for you guys to have that additional practice. Tomorrow, I'll spend the first few minutes, just kind of make sure that we are good with all the formulas and the types of problems, answer any last minute questions. And then you guys will take the quiz after 5 or 10 minutes, once class begins. Okay. I'll do a help session this, during fifth period, if you want to come, if you have, lunch fifth period. Otherwise, I think if you're comfortable with this worksheet, you should be good for tomorrow's quiz. Okay, make sure you bring your calculator. I'll be sure to send out a reminder this afternoon. Okay, come up and get your phones.
How many questions are on the quiz?
5 problems.
I've never like felt somewhere. Ever we have